Good morning, Precalculus. Okay, so today's lesson is going to be on solving systems of two equations. It's going to look like a review lesson, like geometry, maybe even algebra. You have learned this before somewhere in your math career. So we are going to solve by substitution today, and we're going to solve by elimination. And then tomorrow or the day after that, we're going to solve using matrices. So this is just a reminder of how we used to do it, and then I will show you I will take it to matrices. No worries. But today, we're just solving by substitution and then elimination. So substitution is where you substitute, right? I have the steps up there. We want to solve for the lonely variable, substitute or plug back into the other equation, then solve for that variable and plug that value back in to find the lonely one. What? Okay, so if one is already solved for, this example A1 is easy. A1 is always easy. So y equals -2. If y equals -2, then I can simply plug in or substitute instead of the value y here, instead of a y, I could put a -2. Yes? So if I rewrite this equation, this top equation, x plus 2 times, not y, because y and -2 are the same thing. So instead of a y, I will put a -2 and then go on with the rest of the equation equals 5. I will use this to solve for x. So what I have is x, well, not plus, it's 2 times -2, so that's actually going to be a -4 equals 5. And then if I solve for x, I would simply add 4, and x by itself equals 5 plus 4, which is 9. This is not my answer though. I have to write the answer in the form with the x and the y coordinate. I have to have the x and the y coordinate. So my x was the 9 and my y from the very beginning was the -2. What I'm actually finding here, x plus 2y equals 5, everything is to the first power. This is a straight line. And y equals -2, that is also a straight line. These are linear equations. I could rewrite them in the form y equals mx plus b. You know that form, the equation of a line, where your m was your slope and your b was your y-intercept. So I could rearrange this top one and make it look like this, and the same here if I wanted to add an m and a b. But these are two straight lines, which means their answer is where those two lines cross. So it has to be written as an xy coordinate. It is not x equals 9, y equals -2, because those are equations of a line. X equals 9 is where you would go to the x-axis and you would go to 1, 2, 3, 4, 5, 6, 7, 8, 9, and you would draw a line straight up and down. That's x equals 9, and that is not my answer. My answer is the point where the two lines cross. We got it? Okay. On to A2. All right, so number 2, I'm supposed to solve for the lonely variable. I don't have one that's already all by itself. This x, though, this x is pretty by itself. I just need to move this -3y. So I'm going to solve for the lonely variable. That's the fastest way to do it. So I'm going to solve for x. So I will, if I'm solving for x, I would have to add 3y. So we'll cancel over here, add 3y. And what I end up with is x all by itself equals 6 plus 3y. I like to write it in standard form, so I'm going to put the 3y first and then the plus 6. But we agree this is the same thing, right? Of course. All right, so now I want to take this rearranged one and plug it back into the other equation. Do not plug it back into the one you just rearranged. That's pointless. Plug it back into the other one. And this was solving for x, correct? So I'm going to plug it in for the x. So now I'm going to rewrite the second equation. So that equation was -2, but instead of the x right here, I'm going to write 3y plus 6. So I replaced the x because it says x equals this. So if x equals this, I'm going to have to write x. I can write this. The rest of the equation says plus 6y, and it all equals 4. All right, so I rearrange, and then I replace. And then we'll just work this out. So negative 2 times 3y is negative 6y. Negative 2 times 6 is negative 12. I still have that plus 6y out there, and it all equaled 4. Okay, so now I want to combine my like terms, so that would be the negative 6y and the positive 6y, but what happens? They cancel. They cancel each other when I try to combine them, so all I have left on the left side is a negative 12, and all I have left on the right side is a 4. Well, this simply isn't true. Negative 12 doesn't equal 4, and if you end up with a situation that is not true, then there is no solution. No solution. Well, how could that be? These are two lines. I was supposed to find the place where they crossed. How can two lines not cross? They're parallel. These two lines are parallel. If I have two parallel lines, they can be two totally different lines, but if they have the same slope, it doesn't matter how long they go on, they will not cross each other. Therefore, there is no solution. So no solution is a situation of parallel lines. Just FYI, you could have an infinite solution. I could have worked it out and ended up with something like, I don't know, 13 equals 13, which is true all the time. So that would not be no solution. That one would be infinite solutions. And that happens when they are the exact same line. So if you worked it out and ended up with something that is true, then your answer would be infinite solutions, and that's when you just have two different equations for the same line. Okay, let's get on to something harder than this. This was too easy. Let's go on to A3 and 4. Okay, A3. I can't find my black marker. I don't know how I feel about my colors. A3. 2x minus 3y equals negative 7. And 4x plus 5y equals 8. And I will send you guys the picture of these examples so you can work them through with me. But okay, in A3, I do not have a lonely variable. Nothing is by itself, so I can choose. Whatever you want to do is your world. I'm going to solve for the top x. Why not? So if I solve for the top x, I would add 3y, and I would have 2x equals 3y minus 7. Okay, again, I'm trying to solve for one of the variables. I chose x. Now, whatever you choose, it should still work out. As long as your math is right, we should all get to the same answer at the end. So I want to divide by 2. Divide everything by 2. Oh no, fractions. So x equals, and I'm going to leave it as a fraction. If you want to change it to a decimal, knock yourself out. But I have 3 over 2y minus 7 over 2, because neither of these reduce. This is my x. I want to take my x after I have rearranged it, and I want to plug it back into the other equation. Do not plug it back into the equation you just rearranged. It's just a loop. It'll get you nowhere. So we'll plug it into the other equation. So instead of, because x is what I solved for, so instead of x, I will plug in all of this with the fractions. So I'm going to rewrite the second equation, which is 4. And instead of an x, I'm going to replace the letter x with all of that. So 3 over 2y minus 7 over 2. And continue the rest of the equation. So plus 5y equals 8. Okay, so I just need to solve this. So I will distribute 4 times 3 over 2. Think of this as a 4 over 1. So when we multiply fractions, we know the numerators multiply, the denominators multiply. So really this is a 4 times 3, which is 12, over 1 times 2, which is 2, and that 12 over 2, which is give me 6. So 6y, see, not that bad. Same thing here, 4 times -7 is -28. 1 times 2 is just 2. -28 over 2 is a -14. Okay, and then the 5y plus 5y equals 8. All right, so when I combine my like terms, my 6 plus 5y gives me 11 y's. And I have -14 equals 8. I will add 14 to both sides. That'll cancel. I have 11y equals 8 plus 14, which is 22. And then I divide by 11, and my y equals 2. It's not my answer. That is not my answer. I will not leave it as y equals 2. But even before I do that, I need to take this and plug it back in. I'm not done. My answer is supposed to have an x and a y coordinate, right? My answer needs to have an x and a y coordinate. Yes, I know that y is 2, but I gotta figure out what x is. So I'm gonna plug that 2 back into the rearranged one. You could plug it back in up here, but this is the fastest route. So x equals 3 over 2. And instead of y, I'm gonna plug in the value 2. Those 2's will cancel. That's one way to look at it, but let's not do that. Okay, so let's say, this is if you don't have a calculator, which I know that you do, but if I didn't, 3 times 2 would be 6 on the top, and that would be a 2 on the bottom. So it would be a 6 over 2 minus that 7 over 2. And if I look at it like that, 6 minus 7 is -1. Right? So my x is -1/2. And again, you could have just plugged it into the calculator, but -1/2 and 2. All right, I'm gonna take a pause in this video because it's getting long, and I will come back with your star and one more problem.